Welcome to our Friday webinar. This is an extension of what we talked about last week, where we were diving into DataGraph 5.0 and giving you an overview of the new things that are in 5.0, as well as an overview of some aspects of the program itself. So I think that this is useful whether you're a new user or an existing user. And today, what we're going to be doing is we're going to be talking about functions and some interesting, I think, and really great improvements in terms of some aspects of using functions within DataGraph, in particular for related to curve fitting. So I'm going to be talking about really there's three main topics that we'll cover in terms of specific changes to the user interface and functionality within the program. The first one that we'll talk about is the new evaluate option within the plot action column. So if you're not familiar with that, don't worry, I'll go over what that is. We're also going to talk about curve fitting higher order polynomials. This is a useful approach if you want to get a sense of a trend of a particular curve that otherwise doesn't have a specific function fit. But higher order polynomials can be tricky. And there was a request from a user to modify a little bit how we reported the polynomials back. So I'll just talk about that and show you, again, how to evaluate and give you an example. I'll also just walk through the actual curve fitting for that with an example from the National Institute of Standards and Technology. So if you want to have your copy of DataGraph ready to follow along with that. I'll show you where you can get the data and we'll work through that example. And then the last thing, and maybe the most kind of impressive thing I think that we have, is a new function library. And that is a functionality that had been requested. Version 4 had a way to save functions, but it really was a little bit limited in that you couldn't really name them. So now we have a function library that you can not only give a name to a function, but you can use those functions in various places, not only in the fit command for doing curve fitting, but you can also use that function library to share with others, which I think is particularly useful. So let's go ahead and get started, and I will share my screen. And I'm going to start with a brand new DataGraph file. The first topic, evaluating functions with the plot action column. First of all, what is a plot action column if you've never used it before? This is a column that is available over here on the left-hand side where we have the column list and other menu, plot action. What is this column type if you've never used this before? This is in the category of a derived type of column. So it reports data from input data. So it performs actions that are mathematical in nature. You can see from the action menu that there are a number of different things you can do here with numerical columns of data: integrate, differentiate, find extreme values, interpolate, binning, smoothing. So there's a lot of interesting actions here that can be useful. What's new is this one down here called evaluate. And if you click this and just create, select that action, you don't see that you can do anything here because we haven't fit any data yet to have a function to evaluate. So this connects to the fit command and will show you different, if you have different commands in different graphs, it will show you those commands in this drop-down menu. So let me go ahead and actually just really quickly, I'll create a couple of number columns. Let me move these over to the side here and put in just some very simple data. So you can go ahead and, try this. So we'll have some X values and some Y values. And actually, I guess I could have these maybe get quite a bit bigger, but just so you have something to sort of play with, and go ahead and highlight those columns. I'm going to plot the points, and then I'm going to do a fit on that data. And now that I have something here within, I have a fit command within my DataGraph file. I can go over to this menu and say function, and now you'll see that there's a function there to choose from. It also will give you that green arrow to show you where you are. So if I have a number of different functions within different graphs, it'll help me to search through them in this menu. And then if I go ahead and select this, oh, I have to do one more thing. I have to tell it what Y values I want to use. And I can just go here and select not the Y values. It's the X values. I don't need the Y values. I need the X values. So you're calculating the Y values as a function of X. So we put in the X values here. Notice that for the Y, you can just leave it as none. It really isn't even using that. At some point, maybe we'll separate this out into a different column, but in any case, this is how this works. So now it's evaluating for you the result of this fitted equation using the fit to this data. So this is my, we'll just call this eval for now. Now, right now, all I'm doing is using the X values I input in. There's actually a very quick way to even get a column that looks like just this from the fit command itself. You can go to the gear menu, do extract as column, and you can extract the fit values. And you'll see here, they're exactly the same. They should be. But what the evaluate column lets you do is use other X values. So let's go ahead and just add in, just kind of divide up this section. I'll put in a new numerical column, and this can be, this is also X. I'll just call it X2. And then if I, put some numbers in here, whatever I want to type in, and I want to evaluate this function I fit at these X values, I can choose that column, and then it's going to evaluate those functions for me, or that function at that location. So in the past, if you haven't upgraded to the new version yet, what you would see is there was a subtract option that we actually did have for a while. And that was useful if you wanted to determine the residuals from a fit at other X locations. Again, if you just extract from the gear menu the residual values, it's just going to give them to you at the values from the X and Y fit itself. But if you wanted to, again, you can do the same thing here. Let me go ahead and highlight these and close some of these. If you wanted to not just evaluate this, but you also wanted to report what the residuals were at that location, then I can make a copy of this column and change this to subtract. And then this would be my residual values, although it seems like it's not happy with this right now. So maybe I have to check that. Oh, because maybe I need to pick my Y values for this one. So this does actually need which sort of makes sense. It's the X and the Y values there. So I could pick my Y values that I evaluated. And here it's just giving me the residual is 0, which makes sense because these are the ones that I just evaluated my data at. Anyway, okay, let's go ahead and keep going to the next section. So what I did so far is I just did a really simple linear fit. But if you look at my fit command, there's all these other options here that we're going to talk about a bit. Now, I guess I will say this evaluate option works with any of the fit options here. It will, again, connect to that command and bring that function, use that function in these calculations in the data table. But what I want to do for the next one, we're going to now talk about fitting polynomials that are higher order, and again, how that's different. And I'm going to use this example from NIST. So let me go ahead and minimize this file and show you, just to start, what we're going to create. So this is a fit of some data using a higher order polynomial. And again, I'm going to show you from scratch how to do this. So let's just pull this away so you're getting a preview of what we're going to do. Bring this back in here. This is a website that has some statistical reference data sets that are very useful for validating computer software code. This is what this was originally, what they produced this website for and what they produced these examples for. So we use these example sets to test our own software to make sure that everything is operating properly and the calculations are correct. So actually, I guess I can show you the data set that we're going to use. If you go to data sets and then you go to, is it under, linear regression. It's this one here, Philip, the polynomial fit that is 11 parameters. So if you go to that page, you can see that there is a plot here of this data with the points. This is a fit that is considered to be a higher level of difficulty, again, because higher order polynomials have to be solved very carefully. And we do that within DataGraph. So we match very well the certified values that they provide. So for all these different samples, they provide you the data, and then they also provide you the certified values. So here's some more information on this data set, shows the form of the polynomial, gives you the results that you would expect to get, and then you have the data down here. So I'm just going to copy this data and now go into DataGraph. Let me go ahead and do a new file now that I have this in my clipboard, and I'll just paste this right into DataGraph. One thing that actually got me the first time, I was just looking at this data earlier just to check everything, that make sure it was working properly, that they have the Y on the left and the X on the right. And I was doing the fitting on this and was a little confused that I wasn't getting the results I expected, but that's because typically I always put the X on the left and the Y on the right. So I'm going to reverse the order here from what this is in that data file. And then when you do that, then it's a lot easier within DataGraph to just highlight the two columns of data and add the points and then add the fit. And by default, what's going to happen here is it uses a linear fit. That's just the default in the fit command itself. And what I want to use is this polynomial fit. The polynomial fit now has 5 parameters in it. So that's not yet enough to fit this data. In fact, built into in terms of the options you have here, you can use a linear, you can use a quadratic, you can use a cubic, but because this data has such a unique trend, you would need to use a higher order polynomial in order to get an actual functional fit for this data. And I think what I'll do here is I'll split. We talked about this last week, swapping the layout, so you can see this command a little bit better. So the certified values that they give in NIST are a 10th order polynomial to fit this data. And actually there's just a slider right here that you can use to change the order in the polynomial. A DataGraph can actually go up to very high order polynomials and give you good results. So I guess the one thing, so what's different here than for other types of fits, if you did, for example, a cubic fit, let me go ahead and open this up. You have, or maybe more the linear fit. Actually, on all of these, I take that back. I was thinking actually we still, in the old version, we had a slider here where you would change the number of digits. And we've removed that now for all the fits. So what is happening is you're getting, not just for the polynomial, but for these other fits as well, the digits that you see reported are the number of digits that you would need to reproduce this line. So let me back up, I guess, a little and talk about what do I mean. Well, if I wanted to take this polynomial itself, so in this fit command, when it gives you the result of the fit, you can actually highlight, and I'm going to copy the polynomial that I have here. And DataGraph also has a function command that I can go and use. So I'll go ahead and add a function command, and I can paste this function into the function command. Now, when I first do this, it's actually going to the range on the function command. By default, it's set to 0 to 1. We might make this a little smarter in the future. But for now, when I paste this in, it's going to a range that's not actually even in my data. So that's not what I want to do. I would really want to do basically the minimum and maximum X value that I'm using right now. And I could create variables for this, but I think I'll just go ahead and use the space bar, do the quick graph here to get the minimum is about -9 and the max is about -3. So we'll just go ahead and use those values. There we go. So now you can see what the result is. Now, of course, this actually sort of illustrates, since I didn't use the exact min and exact max, illustrates what happens when you have higher order polynomials and you go outside of the range that you've used to fit the data. And here this is going way off where you might think the trend would go. So for higher order polynomials, it is actually pretty important to not extend beyond that range. So that just sort of illustrated that pretty well, and probably the same for the other end. I should maybe be a little more careful to really show that more exact. But the line that you see from the function command, if I go ahead and just let me make this a different color and then move this to the top. So if I make this really wide, and I'll also make my line from my fit command a little bit wider so you can see this, then these two lines clearly match very well. And so there's no problem here. So in the past, in the older version of DataGraph, you could arbitrarily change the number of digits that you saw within the fit. So if you only wanted to report back 2 digits or 3 digits in terms of significant figures of the fit parameters, you could change that with the slider. But if you, particularly for the high order polynomials, say you only had 1 or 2 digits being reported, and you took this function and pasted it into the function command to plot it, you would get results that were sort of garbage. With these high order polynomials in particular, you really have to make sure you report a lot of digits for these high order terms to make sure that you would recover the calculated value. So when you look into, again, some of these really, high order terms, there's a lot of digits behind these. Now, in general, I would say we don't necessarily recommend always doing this. If you have a very high order polynomial, there is some limit to the number of digits that we can report here. However, you can, even if the digits that are reported aren't able to represent the polynomial in the function command, you can still use it to evaluate that reported polynomial. So you will see let's see, I don't want to hide that one. Let's hide this in. You'll see the line from this polynomial, and the evaluate function that we just talked about, that functionality in the plot action column, you can select these. So I'll just do that quickly. Let's swap this back, bring back the data column. Again, if I have a plot action column, I can now select my X values. I can do the evaluate option, and I can select this function from the fit command. And again, it's going to now return these values. So that's, in some ways, this really is the preferred method of doing evaluations of higher order polynomials is to use this plot action column. But if you're, inclined to plot the function or to use the function command, at least now you know how you can do that. Okay, so let's go ahead now and move on to the last part of the webinar, where I'm going to talk about the function library and how that works and how you can set that up. And for this example, I'll go ahead and use one of our online examples. And I already filtered this, just typing the word non for nonlinear curve fitting, because these are examples where we've specified a function that we're using in the arbitrary fit option within DataGraph. So let's open the first one. I really like this one. I've shown this one before because this is actually data on the growth of my puppy. And I should probably update this because I have more data now predicting how big we think she's going to get. In any case, this is an example where we have a function that I've entered into the arbitrary fit function. So this is our arbitrary fit option. So again, one of the options from the fit command is arbitrary. And when you choose that, let me just do one from scratch just so you can see this. So if I took my data and I did a fit command and you choose arbitrary, what happens is that it just by default will just put in this simple function here. And so maybe I should say first, in the past, you would click on this gear menu, and in the gear menu itself, you could save functions that you would type into here. So you could input a different function and then save this, and you'd have a list here that showed you all the functions you saved. But again, you couldn't really name them. And what you see here now is that now I've created a bunch of different types of functions. These are in groups. So I've created a simple group for trigonometric, a group for date and time functions, and another group that I just call my functions. And I've already saved in this the growth curve. So to show you how I did that, first of all, if you have a function that you've already entered into DataGraph and you want to put it in the function library, then you click on the gear menu and you can say add to library. So I'll do that. And now I've just added this to my library. That's all I needed to do. Now, when I go back over here and I click the gear menu, you'll see that same function shown, and I can select it and it will update the function that's selected for this particular fit. Now, here you can see it doesn't have a name. It's just shown me the function because I haven't entered that yet. So you can just, very quickly get a function in there and use it in different places. And again, this is a library that's now in your copy of DataGraph. So any DataGraph file you open, it's going to show you these functions, not just, a particular file. But if you go down to the bottom here, you'll see how there's also an option of editing the library. So let me go ahead and click that and show you how you can now edit this. This opens up this new preferences panel that we've added. And it's showing me now, here's the section on the function library. I have my trigonometric functions I created, my date and time functions, and what I call my favorite functions. I already had the growth curve in here. So I actually don't really need this function in here now. I think I'm actually not sure if I just hit delete, if it gets rid of it, and it does. Okay, so I already have the growth function that I named. So when you add functions, you can actually do it through here directly. Click, if you look up top, there's an add function button that gives me a new line. If I want to group the functions, then I can select group. And now it creates this group that actually is something I can kind of drag around and put. Right now it's inside this group. I can move it outside the group, my favorite. So you can nest groups of functions within other function groups. And so I've just added in now some other function as well, because what you'll notice here, some of the functions I've added are not like the growth curve, not things I'm using in the arbitrary fit, but actually functions that I'm using within my data table to perform other actions. So the functions that you add within this function library are not only accessible from the fit command, but you can access them from expression columns as well as from the expression variable where you're performing calculations. So if I open, for example, just a new file, and I add an expression column, so that would be here. Oops, sorry, that would be here. Now in this expression column, if I click the gear menu, you now have a new option for function library, and it's going to show me all those functions that I had created. Now I have one that's empty. It's that one that I just created. But if I want to, save, and if I use this function very often, I can go ahead and add it with that gear menu. So very handy for saving functions. And if you currently use functions at all, often what I do is I go to the help menu, and that's bringing up the community board on my website. But in there is a list of functions that you can access. Might as well just show you this. So that just brought up the knowledge base. And if I go to the function reference, then you can see all these different functions here. Now, one thing that I haven't done yet is I was thinking about just making some files that included all of the standard functions within DataGraph, so that you can import them if you would like. Because now when you see this, you're not going to see anything in the function library unless you've specifically added it. So really it is yours to customize your function library as you like. But you could do the same thing I've done here, add a number of the built-in functions that you use regularly, or other functions that you want to use in calculations. Now, I don't have any variables with these names, so it's going to give me an error here. But also, again, the expression variable, if you're doing some calculations in expressions, same thing. You're going to see this function library here where you can pick any of these functions to use within your file. And that's sort of the crux of it. Oh, I guess the one important thing, this is what I didn't show you. So when I go into the function library, if I say edit library, it'll open it. I can also open this from the preferences menu directly. If you go under DataGraph preferences, it opens this preference window. But so the last thing here is that if you click the gear menu, you can export whatever functions you have selected. That will create a file that contains that is a file that you can save with other people. And then you'll see how there's import from file here also that allows you to take a file that someone else has created and import it into your function list. And that's the thing that I think is really cool. So we could, really have some curated lists of functions that are common for different fields. If you have a list of functions that you use within your research group, then you can create a file that you can share with other users. And so I think this will be a very useful functionality. For next week, what we're going to talk about are actions in the data table. And there's a number of shortcuts that have been added for scaling multiple columns of data, performing actions on multiple columns of data, some improvements in terms of importing and exporting data that we'll talk about. And so I think that'll hopefully be useful as well. So we'll continue for the remainder of this month, really focusing on DataGraph 5.0 and some of the changes and improvements that are in the program. And that's pretty much all that I have for today.